Everybody. In this video lesson, we're going to develop some skills. We're going to learn how to multiply and divide rational expressions. So let's get started. So to be clear, what we're doing today, it's a skill. It's an algebra skill. We're not learning anything really new conceptually. We're just developing our algebra skills further. And the reason we need to get comfortable working with rational expressions is because they appear a lot in real life, especially in the field of physics. So engineers, scientists, mathematicians. Most of you guys, I think you guys finish your grade 10 science course, and I know one part of the science course is optics, and this is the lens equation, and it involves rational expressions relating the focal length of a mirror with the distance of the image and the distance of the object. Some of you guys may be taking grade 11 physics right now, and you'll talk about electric circuits, and you'll see that the resistance and voltage in an electric circuit is related by rational expressions too. So we need to be able to work with them. You'll need to be able to work with them when you get to the calculus course. And so this is a day in this course where we spend kind of developing that skill. But as I said, it's not really a new concept. It's just an algebraic skill. So here's what we're doing. I have two rational expressions there, and we want to multiply them. And just as an aside, and we'll do this the next day when we compare adding rational expressions, but multiplying rational expressions together, it's like multiplying fractions together. So if I said we have 2/3 times 5/7, let's say. The rule you guys learned in earlier grades when multiplying fractions is you multiply the tops, 10, and you multiply the bottoms, 3 times 7, 21, 10, 21, 10, 21sts, something like that. But that's how you multiply fractions. That's how you multiply rational expressions. Now, sometimes when you're multiplying fractions, and so let me make up this example. Let's just do an easier one. 2/9 times 3/10. Let's do that. This gives you 6/90, but that can be reduced to lowest terms. That can be reduced to 1/15. So instead of having to reduce at the end when the numbers are really big, sometimes, and maybe you did this with your teacher, but sometimes you can make things a little more simplified before you do the multiplication. For example, I'm using orange. For example, I see 2/10, and I know that 2 divided by 10 is going to give me 1/5, right? And I see a 3 on top and a 9 on the bottom, and I know that those divide out too. 3/9 is the same as 1/3. And now that I've done all the reducing first, while the numbers are small, I can now just multiply those together. 1 times 1 is 1. 3 times 5 is 15. And we get the same answer either way. It's just, would you rather simplify at the end, or would you rather simplify at front? And for as many of you are out there watching, there's as many ways people like to go about this. So I'm going to do this one 2 ways. And then you can just choose whichever feels good for you, right? So method 1 is kind of like what I did with the first one here, is I just multiplied first and then I simplified. So I think I have space, so I'm just going to recopy it out. I don't know if this is entirely necessary, but. So we're going to multiply these guys. Now you learned in your grade 9 math course how to multiply monomials. We use our exponent rules. 4 times 12 is 48. X squared times x cubed, you add the exponents, that's x to the power 5. On the bottom, 3 times 2 is 6, x times x is x squared, and now we can simplify. 48 divided by 6 is 8. X to the power of 5 divided by x power 2 is x to the power of 3. And that's fully simplified. And the one thing we do with these questions too is we state restrictions. So just like our previous lesson, when working with a rational function or expression, after we do our simplifying, we're going to write out what makes the bottom 0 And in this case, if you look at either one of these guys, and in this case, it's both the same. What makes this bottom 0? What makes that bottom 0? I think it doesn't take a lot of work to see that you can't plug in 0. X equals 0 is a restriction for that one. So you can multiply first and then simplify, or you can simplify and then multiply. So I'm going to rewrite 4x squared over 3x times 12x cubed over 2x. I'm going to switch to a different color, and we're going to go a little crazy with the simplifying here. So, you know, if you just like to multiply then simplify after, that's totally fine. But, you know, some of you who can keep your thoughts organized, like this might work for you. But 12 over 2 is just 6, right? And then if I look at like each pair here, I've got an x in the bottom and an x on top. Those can divide out, right? I have 2 x's and 1 x, so I can just cross out one of them. And then I have an x in the bottom here, x cubed, so that would go down to x squared. And I can maybe just rewrite everything that I have now. So doing some simplification, I would now have 4x over 3 times 6x squared. And on the bottom, there's just nothing over 1. I guess I could have done another simplification, right? Because 6 over 3 is equal to 2. Yeah, I might actually just do that just for the sake of completeness. I think I do. If I'm doing simplifying, I just want to make sure everything is simplified like completely. So I'll use a different color because like I'm now doing a second layer. But yeah, 6 divided by 3 is 2. And there's no more simplifying I can do. So what's left? We've got purely 4x from the first bit, and then purely 6x squared, 2x squared from the second bit. And you may have noticed already that that does give you the same answer. 2x squared, 8x cubed. Again, x equals 0, the one thing that makes the bottom 0. Now, for me personally, for this example, I think it's easier just to multiply, and then that wasn't too hard to simplify afterwards. But in some situations, the numbers were bigger. I don't know, maybe method 2 is easier. But yeah, in my opinion, I like method 1. I might use method 1 more often than not. But yeah, just those are options for you. Ultimately, you can do what you're comfortable with. As you see on the right with fractions, you can multiply and then simplify, or simplify and then multiply. Works the same way with rational expressions. Pick the method you like best. Let's do a division example. So you guys have learned in previous grades that you can take any division question that involves fractions, or in this case, rational expressions, and turn it into a multiplication question by flipping. And the saying is invert and multiply. So change this question to a multiplication question and then flip 12b squared over 15a squared. I mean, that's literally just how you divide fractions. It's something that kind of should be in our math toolbox at this point, and that's how you go about dividing rational expressions. You just flip the second guy and multiply. Now let's proceed. Honestly, I don't think it's too bad just to multiply these guys. So that gives us 1200 a, and then we have b squared, so that's b to the power of 4, divided by 4 times 15 is 60. A times a squared is a cubed. So, you know, the thing is, if you want to do this method, you have to make sure you're good at simplifying at the end. So I'm looking here, 1200 over 60. So I know that that's 20. You could on a calculator do that. But yeah, just simplifies to 20. Now I'm going to look at the a's. So I have a to the power of, I have 1a on top and 3 on the bottom. So ultimately, when I divide those out, a divides with one of these a's in the bottom. I'm left with a squared on the bottom, and I just have a b to the power of 4 on top. So this is our simplified expression. this expression earlier, or this division of two rational expressions, ultimately simplifies down to 20 times b to the power of 4 divided by a squared. Let's talk about restrictions. When you divide rational expressions, you have to be kind of careful. There's actually, so we have to check what makes this bottom equal to 0. Well, a can't be 0. And what makes this bottom 0? B equals 0, or b can't be 0. But there's one extra thing you have to check in a division question as well. Because ultimately you flip and multiply the second guy, you not only have to check the bottoms of each of the originals, you have to check the top of what you're dividing by to make sure that doesn't give you 0 as well. Now in this case, 15a squared, that restriction, what makes that 0 would just also be a equals 0. And so we've got them all here. But in practice, so take note of what I'm saying, when you're dividing rational expressions, you're gonna have to check the 3 spots. The bottom originally, but then when you flip, you get something different on the bottom. So keep that in mind. I've given you some more examples here, but I've kind of structured them and given you some scaffolding to help you work your way through. You can pause and try working through that on your own, or you can follow on with me. So we now have experience when we have a rational expression. If it looks like it can be factored, then we factor. So, and this one's not too bad. It's just common factoring. So we have a times a plus 2 over 3a. We have 20a squared. And on the bottom, common factor this guy, 5a times a plus 2. All right. So at this point, you can just multiply things together. I've prompted you to divide out common factors. So what I think, in my opinion, would be easiest here is just divide out the a plus 2. And what are you left with? I'll write this out. A over 3a times 20a squared over 5a. And if you're like, well, Mr. Smith, more can be canceled. Absolutely, do whatever makes you feel comfortable. From my experience, like many students are a bit more comfortable if we just divide those brackets out and then just do this as a multiplication. We get 20a cubed over 15a squared. 20 over 15 simplifies to 4 over 3. And a cubed divided by a squared just gives you a. So this big mess, pretty neat, actually just simplified down to 4a over 3 in the end, and we have some restrictions. What makes this bottom 0? A can't be 0. What makes this bottom 0? Hard to tell initially, so we look to the factored form, and then we can see a can't be 0, which we've got, or minus 2. So you can write that out in 2 separate ways like that, or you could probably write out a can't be 0, comma, minus 2, something like that, whatever you prefer. But yeah, the idea is, guys, when we're simplifying rational expressions, or in this case, multiplying, simplify them first by factoring, because then you might be able to make what you're working with like less complicated. And then once we did that, as you guys saw, it was kind of like a question like our first example we did together. Can you guys try this one? So we're dividing two rational expressions. So I prompted you to factor where possible, and none of these require decomposition. So I don't think that should be too bad. And then we'll proceed like I told you guys. Rewrite as a multiplication, divide common factors. Let's see what that looks like. So we get 2x times x minus 4. And what multiplies to negative 10 adds to negative 3. That's negative 5 and positive 2. Ideally, we are kind of at the stage where we could factor a simple trinomial without too much effort, maybe even without any jotting down what we're adding to and multiplying to. But if you need to, that's fine. Plus 4x squared over x minus 4 x minus 5. It's minus 4 and minus 5 that multiply 2. Multiply 2, 20, and add to negative 9. Now, before you do any dividing out, you have to be careful that you can only do that when we have it as a multiplication. Let's rewrite it as a multiplication. And all we do is we invert and multiply. Flip the second guy, change it to a multiplication question. So now we're ready to go. And now you can see the only brackets you can actually divide out are the x minus 5 guys. X minus 5 over x minus 5. And yeah, let's just write it out. As usual, if you feel like you can do multiple steps at once, then you're more than welcome to. So now we can multiply. So what we get is we get 2x, and we actually get 2 factors of x minus 4. And all over, we're going to have 4x squared and x plus 2. And now we can just simplify this a little bit because 2 over 4 is 1 over 2. And x over x squared, well, we're just left with x. So we have on top x minus 4 squared. On the bottom, we have a 2, we have an x, and we have an x plus 2. And that's fully simplified. Being factored is nice. Don't feel the pressure to expand back out again. This is perfect. Now we have to state restrictions. So let's go back. And right now, it's hard to tell what makes from the original. What makes the bottom 0? That's what we factored. So looking at this step, what makes this bottom 0? 5 and negative 2. So x can't be 5, negative 2. So let's look at the second fraction. X can't be 4 or 5. Well, we have 5, so x can't be 4. But guys, you also can't divide by 0. So check that out. You can't divide by 0. 4x squared can't be 0. This is also evident when you wrote it as a multiplication. You can't have a 0 on the bottom right here. So x can't be 0 as well. So you can just write the restrictions as a list of numbers. They don't have to be in order. Yeah, guys, that's kind of like as complicated as it gets. And again, the reason we do exercises like this, and while you practice a few of those, is not because this level of problem comes up all the time. It's because we're exercising and we're developing skills and getting stronger with our math skills. You'll have to divide some rational expressions in calculus, but it's not at this level. But we do these now just to get stronger, right? I've mentioned already, we have to consider when any time where the denominator can be 0. And I've told you to look both in the original and after you do the flip if you're doing a dividing question. So now that we've done some examples multiplying and dividing, you guys are going to practice up a little bit. And then we'll talk about how to add and subtract. And then keep in mind as you're going through these, and maybe if you're having a difficult time and need to get help, is that we're not doing this every day. Once we learn how to do this, the purpose is to expose you to the skill. So when you come across in grade 12, at the very least, like, okay, yeah, I've done that before. So now I'll just practice up a bit and get better at it. But we're not once we do this next lesson, we don't really make use of working with rational expressions for the rest of the year. It's completely a skill building exercise, but in the curriculum, we're required to do it. So yeah, just stay positive, just practice. And, if you were here starting, then hopefully you get up here after practicing a bit. And so everybody, we want to get improving a little bit. But until our next lesson, hope you guys are staying well. Have a great day, and we'll see you soon.